2-6, rates, ratios, and conversions. So we're starting with ratios first, and a ratio compares two numbers by division. So it can be written as a fraction, A to B, with a colon in between it. Couldn't remember the name of it. A to B, or A with the word to T-O-B. We also talk about rate in this section. Rate is a ratio that compares quantities in different units. Miles per hour, cups per serving, those are all types of rates. We can also talk about unit rate. Unit rate has a denominator of 1. So on a map, you always have an actual unit. 50 miles is 1 inch. So if we wrote that as a fraction, 50 miles over 1 inch, then that is your unit rate. The inch has to just be in the denominator. So if we look at a sample problem of that, we have a problem that says Bellingham, Washington had an area of 25.4 square miles and a population of 74,547 people during 1 year. The reason I picked that is that Bellingham is about 60 miles from where I grew up. So I like this problem. Bakersfield, California had an area of 113.1 square miles and a population 295,536 during the same year. Which city had a greater number of people per square mile? The reason I slowed down in people per square mile, that's how we set up our units. So with Bellingham, there was 74,547 people and 25.4 square miles. So we'd go people per square mile. Bakersfield, we can do the same thing. We could set up our unit of 295,536 people per 113.1 square miles. So then all we have to do is divide those two numbers. And when we take our 74,547 divided by 25, we get 2,934.9 people per 1 square mile. We can't have 0.9 of a person, so we would just round down because you can't have 0.9 of a person. 2,934 people, I'm going to abbreviate it, per 1 square mile. With Bakersfield, when we took the 295,536 people divided by 113.1, we get 2,613.1 people per square mile, so we round that to 2,613 people per 1 square mile. So Bellingham ended up having the greater population per square mile than Bakersfield. So if we go down further, we can talk about conversion factor, equivalent measures in different units, but they mean the same thing. So 1 foot I know is 12 inches. So we can take this unit rate, like 50 miles per 1 inch, those represent the same thing on a map, and go from equals to a fraction. 1 foot is 12 inches, 3 feet is 1 yard, and those are your conversion factors. And how we use those is in unit analysis. Some books will call it dimensional analysis. And what you need to do is do some conversions. We have 63 yards and we want to convert to feet. To do the dimensional analysis, our 63 yards, I want my yards to cancel, so then I'm writing a conversion factor next to it to get it to do that. And I need yards to feet. Well, I know 1 yard is 3 feet. So I'm going to be multiplying 3 times 63. A lot of my students have sat there for a long time figuring out if they multiply or divide. They know it's by 3, but they don't know which one. This takes out any guessing, because now my units cancel. All I'm left with is feet. 3 times 3 is 9. 3 times 6 is 18. So I get 189 feet. If I have 68 hours per day, and we want to convert to days, then my 68 hours, I want the hours to cancel, so I need a unit with hours and days. So I know there's 24 hours in every one day. So now I have to take the 168 divided by the 24, and that is 7 days. And again, my hours would cancel. The only unit left is days. When we get further in math and further in science, you will have to do conversions like this. It's real common in chemistry to have to convert units over, so this is just getting used to it and starting. So this one is 2 quarts per minute, and we want to convert to gallons per hour. So if I look at my 2 quarts, my quarts I have to turn to gallons, so I know there's 4 quarts in every 1 gallon. That would eliminate my quarts and 9 gallons. But that's gallons per minute, and I want gallons per hour. So minutes I have to cancel. So I want minutes per hour, and there's 60 minutes to every 1 hour. So you can use more than one unit rate to help you convert from one unit to another. So when I multiply straight across, I get 2 times 60, which is 120. My minutes canceled, so I have gallons. My units on the bottom, 1 times 4 times 1, and the only thing left is hours. So 120 divided by 4 is 30 gallons per hour. So if I took that same problem, starting with the 2 quarts per minute, and wanted to go gallons per second, then I can do the same thing. My quarts I want to cancel, so there's 4 quarts in every 1 gallon. That gets rid of my quarts. So now I have gallons per minute, but now I need seconds. So my minutes would go on the top, seconds on the bottom. So for every 1 minute, I have 60 seconds. That would cancel. 2 times 1 times 1 is 2 gallons. On the bottom, 1 times 4 times 60. 4 times 6 is 24. 10. And the only unit left is seconds. 2 divided by 120, if you simplify that fraction. 2 times 1, 2 times 120 gallons per second. So 1 over 120, or if you want 1 divided by 120, is 0.0083 repeating gallons per second. So we could write it in either unit 1/120th or the decimal 8 thousandths, and we would be done. So those are some examples of your rates, ratios, and conversions. Now you may start your homework on 2-6.